All right, you guys, so let's keep going with some more practice with reviewing factoring quadratics. All right, so same idea. I'm going to do 2 times -9. So I get -18. Okay, make sure you include, okay, the positive or negative sign that may be or may not be here. All right, and then +7 at the bottom. All right, so 9 and -2 will solve that because 9 times -2 is -18. And 9 plus -2 would give me 7. All right, so x plus 9, x minus 2. Got to undo that multiplication step. So I divide by 2. I'm dividing by that front number. Okay, so, oops, this slide, 2 gives me 2x plus 9. Then 2 over 2 gives me x minus 1. Okay. Parentheses, remember you can type in x minus 1 first. 2x plus 9 second. Okay, what's most important is that you don't type x plus 1 and 2x minus 9. Okay, make sure that whatever you've decided here, okay, maintains itself over into the next step. I'll submit my answer, and there we go. All right, so let's move here on to level 3. And really all it is as you progress through the assignments, level 1, level 2, level 3, it's just they start, okay, getting into all the different scenarios that are meant to just make sure you're challenged and you're thinking and you are making that multiplication step correctly. All right, so 5 times 8, that's +40. And at the bottom is -14. And then again, this is just where your multiplication tables are so important and why you should just, as much as you can, practice your multiplication tables. All right, so -10 and -4. -10 times -4 gives me 40, +40. And when I add -10 plus -4, I get -14. So that gives me x minus 10 divided by 5, x minus 4 divided by 5. Okay, so that becomes x minus 2. 5 comes to the front, 5x minus 4. Okay, and just remember, type this one into Desmos, type this one into Desmos, and if you get the same parabola, you've done it correctly. Okay. All right, moving right along because on it really gets very repetitive, okay? All right, yes, let's look at our multi-step factoring, okay? All right, so some of you might be thinking, uh-oh, she's got x to the third in there, okay? Well, we got to do a little bit of work with our greatest common factor. So -4x to the third plus 44x squared plus 48x. Okay, so all of these have an x in common, okay? Because remember when you do the GCF of exponents, you take the smallest exponent, and then all of these numbers are divisible by 2, but they are all divisible by 4, okay? So you have to divide by the greatest common factor. So the greatest common factor. Okay, so 2 is a common factor, 4 is the greatest common factor. Okay, now when my problems start with a negative number, I use a negative number as my common factor. Okay, and then you take the smallest exponent value, x. Okay, all right, and now let me use a different color here. Okay, what I'm going to do now is I'm going to divide by that greatest common factor. And I'm going to write that out front. And then in parentheses is going to be the answer after I divide. So -4 divided by -4 is +1. I don't need to write a +1. I subtract my exponents. 3 minus 1 is 2. So x squared. Okay, and I chose not to write the 1 that would have been there. 44 divided by -4 is -11. 2 minus 1 is x. Last term, 48 divided by negative 4 is negative 12. And then the x's eliminate. Okay, so that is my first step. Okay, now when it says factor completely, okay, I always taught my Math 1 students, I said, that is a huge hint. That means that is telling you, they're trying to tell you over and over again that you will likely 100% have to do another factoring step, meaning what's inside the parentheses after you've done this can be factored again. Okay, so for the time being, I'm just going to ignore the negative 4x in the parentheses. I'm going to focus my attention here, and I've got negative 12 on top, negative 11 on bottom. All right, and that's going to be negative 12 and positive 1. Okay, because negative 12 times 1 is negative 12. Negative 12 plus 1 is negative 11. So I'm going to have negative 4x, parentheses, x minus 12, and then x plus 1. Now I'm done here because I didn't multiply. That started with a 1, and when I have a 1 there, I don't have to multiply to get negative 12 on the top. So I don't have to undo the division step. Now you could, you're just dividing by 1 and there'd be no change anyways, okay? So this is my final answer, okay? Now, negative 4x, parentheses, oh, it's not typing, negative 4x, parentheses. Remember, I can type x plus 1 first, even though it's not my answer first. It could be in yours. X minus 12, close the parentheses. Submit my answer, and there you go. Okay, so same thing. He took the greatest common factor as being negative 4. All right, new problem. 5x squared minus 15x minus 50. Okay. All right. So now as I look through, they all do not have a variable in common because this 50 is just a constant. When it's a number by itself, it's just a constant. So there is no greatest common factor that's a variable this time. But if I look at 5, 15, and 50, they can all be divided by 5. So in this particular problem, my greatest common factor is just 5 on its own. Now, why didn't I use negative 5? Because here, that's starting with a positive number, so my GCF will also be a positive number. It's all about the first term, not the ones over here. Whatever's first, okay? All right, so I'm going to divide everything by 5. So 5x squared divided by 5, well, that's just x squared. Negative 15 divided by 5 is negative 3. Bring the x down. Negative 50 divided by 5, negative 10. Okay? And again, factoring completely means I need to attempt to factor this again. So negative 10 on top, negative 3 on the bottom. So that's going to be negative 5 and 2. Okay, I did not multiply because it was a 1. I don't use 5. 5 is just hanging out by itself for the moment. So 5 comes back because I'm ready to write my new parentheses. X minus 5, x plus 2. All right, and just like the problems we were doing, you can type this one into Desmos, this one into Desmos, okay, to check that your work is accurate, okay? All right, so if I type that in, 5 parentheses x minus 5, and then x plus 2, submit my answer, and there we go. Okay, all right, let me check these problem types. Okay, let's look at a difference of squares twice, okay? Just in case you're given that one, and that will cover the rest of the assignment, okay? So, x to the 12th minus 1. All right, so what you may or may not remember is a difference of squares, okay? You may be looking at it and think, well, I remember your teacher saying a squared minus b squared, and that factored to a plus b, a minus b, okay? Basically, it was the same thing, except one had a plus, one had a minus, okay? And that's exactly what happened. So if you had, most of you probably were very familiar with an example like x squared minus 9, and you were like, oh, okay, x plus 3, x minus 3, because you could take the square root of 9, and the square root of 9 was 3. Okay, x squared minus 12 secretly is a difference of squares, okay, because it is x, okay, to the 12th minus 1 squared, but 12, okay, that's divisible by 2, okay? So watch what happens when I write x to the 6th minus 1, x to the 6th plus 1, okay? I could evenly split that exponent in half, okay? Because remember, when you have x to the 6th times x to the 6th, your exponent rule says that you add the exponent, and that would now be x to the 12th. So that's all I did here, okay? So as long as it's divisible by 2, that's what I do in my next step. Okay, now the reason it's a difference of squares twice is because it's factoring completely, which means there's another factoring step. Okay, it's this one, it's the minus sign, okay, because you're looking for a difference of squares, because these are squares, your a squared and your b squared, those are squares. The minus sign is difference, okay, so that's why it's a difference of squares. Okay, so this one is also a difference of squares. It has even exponents, and I can take the square root of 1. So I can do that one again, and 6 divided by 2 is 3. So x to the 3rd minus 1, x to the 3rd plus 1, bring down x to the 6th plus 1. So it's only the minus sign, okay? So I always told my students, I said, first thing you're looking for is even exponents. Okay, you're looking for a minus sign. And you want to have perfect squares. It's like the square root of 36 is 6. The square root of 49 is 7. The square root of 100 is 10. Okay? If it doesn't have these three components, you cannot factor again. So because I started with a minus sign, I broke it down into 2. Because this one had a minus sign, I could break it down again. Okay? Now, I'll be honest. If you followed all of this, okay, you've got it. Okay? I promise you, you're in really great shape. Okay? For those of you who are sitting thinking, watch the video again. Okay? And just when you get to problems like that, just go slow. Okay? Just go slow. All right. So let's type this in. So parentheses x to the 3rd power minus 1, 3rd power minus 1, parentheses. Okay, I'm going to actually copy and paste this. Oops, it didn't work. Hang on. Parentheses x to the 3rd. Now I'm going to do plus 1. And then parentheses, I got that, x exponent to the 6th plus 1, parentheses. Okay? All right, submit my answer. Yes, and there you go. So see, difference of perfect squares, still difference of perfect squares, and you're good. Okay? All right, if you've got any questions or you get stuck on a problem like this, just shoot me a screenshot, send me a picture, and say, hey, Ms. Barfield, I need some help. I'll be happy to help you. I'll help you, give you some hints, whatever you need. Okay? But I think you're in good shape. And remember also too, you can use an alternate approach to factoring based on what your previous teachers have taught you. All right, good luck, you guys.